Welcome everyone to this video. Um, this um, this is another video in my sequence or series of videos related to cybersecurity and machine learning. This is a new book that I published recently that is available from Amazon. And what I plan to do with this is, I will do short videos on the different topics that I have in the book. And I'm just doing this randomly. I'm not really even following specific flow. So this would be section 7.2 of the book from chapter 7, which is on cybersecurity and machine learning, and the specific topic is malware detection. So in this case, actually, I'm looking at one of the very interesting things that you can do leveraging deep learning models, very deep neural networks. So in this case, the topic is transfer learning for malware detection. So this is a recent project that I worked on in 2022 with some of my students, and it basically has to do with how can we leverage something as powerful as a ResNet. If you remember, a ResNet is actually a very deep neural network that has been pre-trained, and it's an image classifier. So that's the world of transfer learning, where we have large language models, where we have image classifiers or generators. But how do you apply those tools, which are pretty fairly advanced, to a field such as machine learning, such as cybersecurity, and in particular, malware detection? Well, so the idea here is, malware is basically some program. Imagine it has been compiled and it's now a binary, what is sometimes we think of as a .exe file in Windows, for instance, in the Windows operating system. So it's going to be a series of hexadecimal values, a raw binary. It's the representation of the files that we find. And so in the operating system, such as Windows, we might have what I'm calling goodware or malware. So goodware would be your normal good programs like your games or Paint or Word, whatever it is that you have available, and it's an exe in your operating system. And then you have malware, which would be programs that obviously try to copy themselves into other programs that may have a malicious payload. So anyway, so in this quick short video, I just want to give you an example of how we can leverage transfer learning. So the key idea, and I don't want to beat around the bush here, just go directly to it. Basically, we have an exe file. Imagine it's this top one, a buffer basically. And if you look, the binary representation of it is just hash values, right? So these hash values, then you can treat them as a string, right? Imagine it's a string of a specific size, let's say 784 in size. And what you can do with that is you can, we all know that there's techniques in programming to take a one-dimensional array and converting it into a two-dimensional array, but just taking segments of it. So here you can see we basically take this and convert it into a grid. And now you can see it starts to look a lot like a picture. And if we know something about hash values and the ASCII table, is that these have equivalent decimal values or string values, right? So we can just convert this to the equivalent decimal values. And then basically now we can leverage a binary and just convert it into a grid. And then that's basically equivalent to a black and white image. We can see here this binary now by just simply doing something like this is formed into an image, which is black and white, and which is what you can see here. All right, so that's the key idea. So the idea is you convert your data set into these image representations, and then once that's done, you can go ahead and train a machine learning algorithm and leverage pre-trained image classifiers. So that's what I'm going to do now. So the book, of course, my book that covers this uh, is here, right? So cybersecurity and machine learning. So this one. So this is the book. And of course, so this has a companion GitHub. So the GitHub has the code in Python and PyTorch. So in this case, we're going to look at the code. I'm in, basically, you can see here the book, first edition, chapter 7, software assurance. So for this example, I provided all the materials, files, etc. But I'm just going to, and there's basically 3 scripts that I provided to do this work. So I really just want to go over these briefly. So basically there's one file, get exes from Windows. So this is basically, if you want to get, I'm assuming you have a Windows operating system and you don't have malware on it. So you're going to have goodware on it. And so basically, you can use this script to just collect all those .exe files and then, build up your data set. Over here, I have, once you collected the data, then I have another script that basically converts exes into images. And I'll show the logic for this is actually very straightforward and simple. And then once you've converted it into images, you can just go ahead and use those images as your training set. Obviously, you would be converting the goodware and malware binaries into images. And then finally, we have the script fine-tune malware model images, where we're just going to leverage one of the transfer learning libraries, such as FastAI, and just basically use that data to fine-tune a ResNet. So let's just go ahead and take a look at the first script. So you can see here, the first script is just a very simple script to be used in the Windows operating system. Basically, you're looking for .exe files, right? And you're just, opening those files and collecting the information that you want to use later on. So you're gonna, collect your data for use later on. All right, the next, so once you've collected all these files, then you can go ahead and use them. So that takes care of collecting the data from the Windows operating system. Then once you have that, you go over here to this this other script, which would allow you to, basically convert exes into images. So this script is pretty straightforward. It assumes you have, a special folder where you've collected all these files, right? And then you're just going to, this is an example of just reading in one and converting it to an image. This script, I think, only does it for one, just to kind of, elaborate how it works. But the basic idea is this function, convert to images, that you can see here. And I really just want to highlight the specific area. So once you've identified the file that you want, you basically do an fread of the file. You convert it into a byte array, convert the exe data to a byte array, image byte array, and then basically you just take this image byte array and you reshape it to the shape that you want. And that's it. Reshape the byte array so it's a square. And that basically takes care of everything. After that, you can just save it as images, as you can see here, using a library such as pill image. And that's it. That's basically the process. So as you can see, first we collect the files from Windows, and then once we put them in a folder, then we go ahead and convert the exes into images. Now, one thing about this, of course, is, the binaries that you collect from Windows are goodware, right? So they're not going to be malware. To obtain the malware, I provided these 2 links, and these 2 links have instructions on how to go to a very nice place, GitHub, where you can download a lot of malware. That is real malware, so of course be very careful when you do something like that. To keep things simple, what I have done is I provided this malware image data set. So what that means is I've provided examples of image goodware and malware, but already converted to images. So they're no longer the exes, the binaries that would run on your operating system. Instead, they're just images. And so that way, at least, you can perform the analysis without worrying about, oh, am I gonna, add malware to my computer? Finally, once you've created the data set of images, then you can go ahead and just, basically build your classifier to detect malware or goodware using the converted images. So you can see that here. This is the script, and it's actually pretty straightforward. This is an example of a few of the images. So you can see goodware, 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 badware. Okay, so these are just examples. You can see also here, so basically how it works, the key aspect is that I'm using FastAI here. I wanted to keep things simple. Basically, we have a function from FastAI to just load the data. The data is assumed to be in folders. So you have all the goodware in one folder labeled goodware, all the malware in another folder named badware. So that's how you get the labels for your individual classes. Okay. So here we load the data here into the data loader DLS. We display some of the images, and then we have a simple function train model. So this basically is called from here. And as you can see, this is the approach that you use in FastAI. So you have a train model, you give it the data set, you tell it that you want to use a pre-trained ResNet 50, and then all the other parameters that you want to specify. You want to use the pre-trained capability of it. So all this is passed to the function train model, and you can see the train model simply from FastAI. It invokes the CNN learner, creates the model for you. You'll give it the data DLS, and then basically you just perform a search for the learning rate. And then once you've found the learning rate here, you just run the simple model.fine-tune, and basically you fine-tune the model. And that's it. That, as you can see, creates the training process, and then you have an image classifier. All right. So that's a quick overview of how to do transfer learning with malware. Of course, if you want to learn more about it, you can take a look at these scripts and follow the book description. All right. This concludes this video, and thank you.